Hello, hello. Good afternoon or good evening or good morning, depending on where you are at. But right now it's 11 p.m. here in the Los Angeles time. And what we are doing is that we'll be solving my first Calculus 1 exam. I sent out an email to my students earlier. I don't know if they are going to come in or not because, yeah, I didn't tell them beforehand. I just decided to do this like 15 minutes ago. But anyway, though, the file will be in the description, and let's go ahead and just get started, right? So the first 10 questions are multiple choice questions, and this test contains limits, continuity, definition of derivative, and also power rule, product rule, and also the quotient rule. So it's just like the beginning of the calculus part. The first 10 questions are multiple choice questions, and then the last 10 questions are short questions. So here we go. For the first one, we're given a limit as x approaching 8 of the cube root of x minus 2 over x minus 8. You're not going to compute this, you just have to identify what this represents. And I will tell you, this right here is from the definition of derivative, which is this form, right? F prime of a. This right here is the limit as x approaching a of f of x minus f of a over x minus a. So that's where this limit comes from. So you can see that this right here represents, I will just say, the derivative of some function. And the value that we are looking at is 8. So f prime of 8. And our function is, well, just look at that part, namely just the cube root of x. And that's it. That's the first part. Well, that's the first answer right here to the first question. And you do not have to compute it, but if you want to compute it, go ahead and just use the power rule and then plug in 8. Right? Might as well. Let's just do it. Might as well. So here we go. F of x. For the cube root, we write it as the 1/3 power, like so. And then right here, since it's a multiple choice question, you can just go ahead and use the power rule, bring this to the front and minus 1, and that way we'll get the derivative, which will be 1/3 x to the negative 2/3. And we can bring that down to the denominator, which will give us 1 over 3. And that's write this as the cube root, and then we have the x squared like so. And then to compute f prime of 8, we just need to put the 8 into the x, so we have 1 over 3 times the cube root of 8 squared. 8 squared is 64, and then take the cube of that is 4, and then 4 times 3 is 12, so we are done. 1 over 12, if you want to compute the value for it. Alright, so that's the first one, and now for the second question, we are going to see the derivative of 10 to the x power. So you guys can go ahead and look at the answer choices and let me know which answer that you think is. Alright, well, 34 people here. Thank you guys so much for coming. Alright, you guys can tell me what the answer is. What's the derivative of 10 to the x power? No, this is not pre-recorded. This is live stream. B. Yes. This right here is just to test the students to know if they know the derivative of an exponential function. When we have 10 to the x is in the exponent. No, I don't need to look at that, but you know I have that over there, right? But anyway, this right here is just 10 to the x, and then we multiply by ln of the base, which is 10, right? So this is it, right? This is it. And of course, you can look at the answer choices, but that's the answer on the board for you guys. This right here, the video will still be available after the live stream. So if you cannot stay for the whole thing, you can still watch it later on. And I will put down the timestamps later on for all the questions. So that way it's going to be easier for you guys to navigate. I am not on campus, I'm at home. So this is my home setting. Yeah. Okay, for number 3, I do have to erase the board in order to write down the things. So, okay. So let me know how you guys are doing. I think I'm just going to do this. Now, whenever I erase the board, I talk to you guys, and then I will just say hi to all the viewers. And when we solve questions, we'll focus on solving the questions. So that way, it will be better, right? You can focus on the solving part. Number 3, we are given that a function is x minus 1 over x squared plus 4x minus 5. And we are going to look for which of the following is true. So I will have to look at the choices. Which of the following is true? I love to ask this kind of questions because this kind of questions, it's not just one question, it's actually multiple choice. It's actually multiple questions in a question. So I love multiple choice questions a lot. Anyway, A says the domain of the function is from negative infinity to negative 5, union negative 5 to 1, and then union 1 to infinity. All right, and B, it says that f has two vertical isotopes. So I'll just say f has two vertical isotopes, and specifically x at negative 5 and also x at 1. And C, f, the function has one horizontal isotope. And I will tell you that this right here is at y equals 1. And then D, f of 1 is equal to 0. And then lastly, to make this like slightly harder, none of the above. Alright, so you guys should also have the time to look at all this. So let me know, which one do you guys think is true? Which one do you think is actually true? Is it A or B? Because they are kind of similar, huh? But firstly, let's make sure that we understand this one. F of 1 is equal to 0. This right here is actually false. So f of 1, meaning that we put 1 into all the x's, so we get 1 minus 1, right? 1 try this. Okay, f of 1, meaning we put 1 in here, and then minus 1 over 1 square plus 4 times 1, and then minus 5. And we see that on the top we get 0. On the bottom, 1 plus 4 is 5, minus 5 is 0. And it says it's 0. Is this true? Of course not. So D is false, right? D is false. No. And then let's look at C. F has one horizontal isotope at y equal to 0, y equal to 1. This right here is also false. And remember, for the horizontal isotope, what we had to do is, we will have to take the limit as x approaching infinity of our function, which is x minus 1 over x squared plus 4x minus 5. And to do this, it's actually really good, because we can just care about the highest power of x on the top, likewise the highest power of x on the bottom. X over x squared is just 1 over x. As x goes to infinity, this right here gives us 0. Meaning that our actual horizontal isotope is actually at y equals 0. Therefore, this right here is false. Alright, so that got rid of C and D. Now, the tricky part is A and B, they are pretty similar, I will say. And then let's see if you guys can get the answer. Oh, Li Xiang 老师, thank you so much for coming. Even though, wow, I'm so happy that you're here. Thank you so much. I'm surprised that you even follow me on this channel too. Wow, thank you so much. All right, the correct answer is yes. A is correct. The domain of this function is that we cannot have negative 5 and also we cannot have 1. So, okay, so for the domain, this is how we do it. Just go ahead and look at the denominator. We want to make sure that x squared plus 4x minus 5 cannot be equal to 0. And we really have to look at how this is. Do not reduce anything for the domain. So if you look at this, factor it, we get x plus 5 and then x minus 1 cannot be 0. So this right here tells us x cannot be equal to -5, x cannot be equal to 1. And that's exactly how the interval notation works, right? We're excluding -5 and also we are excluding 1 here, so same thing. Yeah, so this right here is actually true. Now, let's see, why isn't B correct? Why isn't B correct? Can you guys tell me which one is the actual vertical isotope? It says it has 2 vertical isotopes. Which one is actually the vertical isotope? Here or here? Hold on, let me see. I see some spam. I have to. Okay. I need a mod, but it's okay. Yes, you guys are right. No, one is not. One is not the horizontal. One is not the vertical isotope. Okay, so this is how we do it. So I'm going to put it right here. So this is B, okay? So when we have a function f of x, which is x minus 1 over, let's factor the denominator. We get x plus 5 and then x minus 1. Yes, we can reduce this. But when you say this is equal to 1 over x plus 5, we have to make sure that we also mention that x cannot be equal to 1 because x minus 1 was on the denominator as well. And if you look at the reduced version, this is where you are going to find the vertical isotope. Because remember, for the vertical isotope, what we are looking for is a non-zero number over 0. So as you can see right here, 1 on the top over x plus 5. So when we have x equals -5, that will cause a 0 on the bottom. So the only vertical isotope is when x is equal to -5. And at 1, in fact, we have a so-called removable discontinuity, which is a hole on the graph. All right, so just to show you guys how the graph looks like real quick, I'll just put it down right here. In order for you to graph this, you can reduce it and then you have this picture pretty much. So you get 1 over x plus 5, meaning that at x equal to -5, we have a vertical isotope. And then the graph looks like this, right? So it will look like this and it will look like that. But earlier we also mentioned that x cannot be equal to 1. So we will have to go to 1 and then we will have to erase that point and we will have an open circle. So that's why removable discontinuity at x equal to 1 and then a vertical isotope at -5. Okay, so just like that. So as I said, I love this question because it goes over 4 little questions. Yeah, and I created this. Okay, so just take a look. All right, cool. Yeah, I was not expecting to do this live stream, so I'm sorry. Maybe next time for the next test, I will make sure that I put out the exam a day before or so that you guys can try it and then you guys will know the live stream. Yeah. Okay, number 4. Earlier I asked which of the following is false. This time we will be asking which of the following is false. No, earlier I asked which of the following is true. Now we'll be doing which of the following is false. Okay, here, number 4. We are considering the function f of x is equal to the cube root of x minus 1. And we are looking for which of the following is false. Multiple choice questions. Right? A is, again, the domain. I'm saying the domain of the function is -infinity to +infinity. B, I'm saying that f is continuous everywhere. And then C, I'm saying that f is differentiable, so of course the shorthand for that is just dable on the interval negative infinity to positive infinity, meaning everywhere. And then D, you know it, I'm going to say none of the above. None of the above. Let me just... Okay, so A, B, C, 我 D. Go, go, go. Yes, Michelle and Andrea. You two are right. The answer for this right here is C. F is actually not differentiable everywhere. So, firstly, when we have a cube root, it's okay to have negative numbers inside. So if you go from negative infinity to positive infinity, it's totally okay. Especially if we don't have x on the bottom or whatnot, right? So the domain is just all real numbers, all good. And likewise, in fact, I can just show you guys the picture, then you guys will know exactly why the answer is like this. When we have the cube root, right, it's just like a rotation or the reflection of the cubic function. And when we have x minus 1, that means we move the curve to the right 1 unit. So we have a 1 right here. And it will look like this. And you will actually have a vertical isotope like that. My picture is not the best, I'm sorry. Let me try it one more time. So it's like this. Yeah, like that. And this is not horizontal isotope either. Okay, let me try. Yeah, like this. So this is meant to be the cube root of x minus 1. So from this picture, we can see that the domain is all real numbers. And from this picture, we can also see that f is continuous everywhere. And from this picture that we can also see f is not differentiable. Because right here we have a vertical isotope. So we have a vertical tangent line. This is a vertical tangent line at x equals 1. So that means our function is not differentiable at x equals 1. All right? And of course, none of the above, it's not the answer. That's all. Okay. All right. I love multiple choice questions, especially which of the following is true or which of the following is false. But when I do the live stream, the only downside is that I will have to write down all the choices in order to make sense. Okay, number 5. We are given our equation y is equal to x to the third power plus 2 over x. And we are going to find dy dx. Namely, the derivative of our function. Okay, so for this right here, some of my students, they see the quotient and then they just go ahead and do the quotient rule. Don't do that, because you don't need to use the quotient rule. Remember to always use algebra. If you can do algebra first before calculus, the calculus steps will be so much better. So if we look at this again, the denominator is just x. In fact, we can split the fraction. We can look at this as x to the third power over x, and then 2 over that. Yeah. And then if you look at this, x to the third power over x is just x squared, and then 2 over x is just 2x to the negative 1. And the reason that we wrote it down this way is because now we can use the power rule. And remember, this is just a multiple choice question, so you can do the power rule. So bring this power to the front, minus 1. The first part is 2x. Secondly, bring this to the front and then minus 1. 2 times negative 1, we have negative, and then the 2. And then x to the negative 2 power. And we can just put this on the bottom, and then that will be it. So 2x minus 2 over x squared. And this right here will be the answer for number 5. Done. Yeah, if you have an... So this is to Kobe in the chat. If you have a which of the following is false question, and if you have like none of the above, wow, that will be... Sometimes it will be too tricky that I will get confused myself because I might forget to put like an actual wrong answer. And yeah. Okay, here's a secret for the people who are here. The reason that I really like to use none of the above for my multiple choice questions is because sometimes I might forget to actually put the correct answer like from A to D. So if I put none of the above, that usually covers my mistake. That's the reason. Okay, number 6. Shall I erase? I will erase. All right, number 6, I will erase. All right, number 6. We are going to see which of the following does not exist. Right, which of the following does not exist. And then again, we will be looking at the choices. The first one is the limit as x approaching infinity, and we will have inverse tangent of x over x. Next one, we have the limit as x approaching infinity, just inverse tangent of x. And then C, we have the limit as x approaching infinity, and we have sine x over x. And then D, we have the limit as x approaching infinity of just sine x. And lastly, you know it, none of, not because not the reason why I have like none of the above, all that stuff. None of the above. Okay. Okay, which one? This right here should be pretty quick. So Addie and Benjamin, yes, you two are right. Yes, it's just D. And of course, I will take some time to go over all this right here real quick, right? So firstly, when we have the, let's do this one first. When we have the limit as x approaching infinity of inverse tangent, this right here gives us pi over 2. And the reason is because, of course, I wouldn't tell you guys to put infinity here. The reason is if you look at the graph of inverse tangent, you actually have two horizontal asymptotes. And the inverse tangent looks like this. This is not a vertical tangent line. The slope right here is actually 1. And when you have the graph right here, you can see this right here approaches the horizontal asymptote, namely pi over 2. If this was x approaching negative infinity, then it will be this, and that will be negative pi over 2. For A, when x is approaching infinity, on the top, it gets to be just pi over 2, right? Divided by infinity, just think about it, a finite number divided by infinity, and we will end up with 0. Yeah. And if you look at C, well, what's this limit, right? One of the ways that you can do it is to look at the picture. For sine x over x, the picture looks like this. You actually have a little open circle here. This is the famous graph. And then you have a curve that looks like this, right? So you can see that the y-value is actually approaching 0. And for this test, the students can use a graphing calculator. And in fact, I went over this in class as well. So the y-value here is approaching 0. That's why this limit does exist. Lastly, D. Sine x is not good at all because if you look at the graph for sine, it looks like this. It keeps going up and down. Between -1 and 1, this right here does not approach any y value as x goes to infinity. So this right here does not exist, right? Okay, Milty, hello. Thank you for turning in. I will do the Chinese version tomorrow because the time will work out much better for the Chinese channel tomorrow. It will be Saturday, so you guys wouldn't be in school or work or things like that. Alright, cool. Oh, from South Korea. Hello. I still cannot pronounce your name, so you will just have to tell me your English name. Otherwise, I don't know how to address you. Sorry about that. Currently taking Cal 3. Oh, what did you guys do? Like the multi-dimension limit and all that, right? Yoo-hoo. Okay, hello, hello. Hello, hello. Oh my goodness, we have 126 people watching. I didn't expect that. Okay, so I'll just take one more question. I do have a video on how to choose the integration technique. You guys can search on just calculus or on my main channel. Right, so I did go over some strategies for that, so definitely check that out. And I would like to just continue because I would like to finish this early because it's 11:25 p.m. here. So anyway, number 7. Let me just tell you guys a story, alright? If you guys have been following along with my shorts, the 100 days of wishing you guys that you can pass calculus, I mentioned that 2 of my students, they were so close of getting 100% on the test. If they got 100%, they would have gotten $20 from me. Right, that's the reward. However, both of them missed this question. Yeah. So they didn't get the $20, but I gave them 5 each. So yeah. Let's see how we can do this. It's a multiple choice question. Again, we can just use the power rule. So this right here, d dx. On the bottom here, we have a square root. Usually we can look at this as the 1/2 power, but since this is on the bottom, so we bring that up and look at that as a negative exponent. So this is x to the negative 1/2 power. And then from here, we do the power rule. Bring this to the front and then minus 1. And we will get negative 1 over 2 x. Negative 1/2 minus 1 is negative 3 over 2. And finally, we just have to clean this up. Put this on the bottom. We have negative 1 over 2. And right here, we see that we have the over 2 for the denominator for the power. We can write that back as the square root. And then we have x to the 3rd power. And let me tell you guys the story right here. Originally, I wanted to leave the answer right here as one of the choices, and that would be the answer for this question, right? But like, I look at my homework list. In fact, I assigned this question as the homework. And on the homework, which I actually did a video on this as well, I wrote the answer as 1 over, well, technically negative 1 over 2. I simplified this. X to the 3rd power is the same as x squared times x. X squared in the square root is just x, right? Because x is positive. So just x times the square root of x. I wrote this for the homework video. So I decided to put this down, which is answer choice D. One of the students who didn't get a 100%, the student had this, and then the student chose a wrong answer. I think the student chose E, so yeah, that's why. So I kind of feel bad, but yeah, just be careful next time. So my students, if you guys are still watching, let me just tell you, I will promise you guys, we'll still be doing this. We have 3 more exams. So yeah. Okay, that's number 7. Now let's continue. Number 8. Yeah, I don't have to erase that because one of the least things I like is erasing the board, of course. So 2x over x minus 7. So you have 2 ways to do this. The first way is you can use a graphing calculator. You can just graph it. And in that case, I will tell you the graph will look like this. You see you will have a vertical asymptote at 7. So let's say this is 7, and then you have a vertical asymptote. The hard part is to make sure that, how does the curve go? And I'll tell you, it goes like this. Yeah, I'll just do like this. Non-draw to scale, okay? Like this and like that. Oh, that's a whole, oh, sorry. That's bad. Yeah. With this picture in front of us, when we see the x is approaching 7 plus, which is, we approach 7 from the right hand side, you see the curve goes straight up, therefore, the answer for this is just past the infinity, and then we are done. If you don't want to use the graph, you can also do the following, if you just want to figure out the answer. Put 7 plus into the x, we get 2 times 7 plus, which is just a positive number, over, put the 7 plus here, and then minus 7. Well, this right here approaches on the top is just a positive number, over, here we have 7 minus 7 is 0. But technically, this right here is a little bit bigger than 7. So I will put down 0 plus. And just like what we mentioned earlier, whenever we have a non-zero number over 0, then you are expecting to get some kind of vertical asymptote, either positive infinity or negative infinity. In our case, positive divided by positive, it gives us positive infinity. So you can also reason out the answer this way too. And that will be it. Okay. Alright, 2 more multiple choice questions. Number 9, and I'm pretty happy because I can fit in number 9 right here as well. Number 9, I'm just going to tell you this is like the hint, right? Use a table of values, use a table, aka calculator, a table of values. So I really have to just make this clear. Use the table of values to compute the limit as h approaching 0, and then we have the cosine of h. This is not cos, it's a different function, okay? It's cosine of h is the input, and then minus 1 over h. So when I say use the table of values, what I'm trying to say is you are supposed to figure out, pick some numbers for h, and then we want to look at this expression, namely cosine of h minus 1 over h. And then just pick your h values. If you put exactly 0, this right here is no good. This right here, because we have a 0 on the bottom, we will get undefined for our computation. But don't do it exactly 0, because when h is approaching 0, h is not exactly equal to 0. Instead, you can pick, let's say, 0.001, and this right here is 0.0001, things like that. And then also do the negative version, negative 0.0001, negative 0.001. And use a calculator to compute, and you will see that this number that we get is very close to 0. The answer for this right here is equal to 0. You can also see that these numbers, they are all approaching 0. Right? So it's just a calculator work, and I think most of the students got this right. So yeah. Technically, we cannot use L'Hopital here because at this point, not only we haven't done the derivative of cosine yet, but also this limit is meant to be done without L'Hopital's rule, because when we try to figure out the derivative of sine cosine, this limit shows up. So we are not supposed to be using L'Hopital's rule. Otherwise, we end up with the so-called circular reasoning. Okay. Number 10. Number 10, I am going to give you guys a graph first. So the graph looks like this. So we have a 2 right here, and we have a clear vertical asymptote, and then we have a horizontal asymptote right here, which is at 1. And the picture looks like this. Goes up, goes like this. But there's going to be an open circle, and we have a closed circle up here. The y value for the closed circle is 4. And then for this right here is 2. My picture is not the best, but please refer to the handout. Right? Please refer to the handout. Okay, question. Which of the following is false? Yeah, which of the following is false? Okay, A, I'm saying that the limit as x approaching infinity of the function, of course this is our function y is equal to f of x. I'm saying that this right here is equal to 1. Next, B, we have the limit as x approaching negative infinity I'm saying that this is equal to 1. So far, is any of this false? No, right? Because this right here is for the horizontal asymptote, which we have a horizontal asymptote here. Likewise, this right here is also for the horizontal asymptote, but just go the other direction. So yeah, these are both true, so they are not the answer. And then let's see C. We have the limit as x approaching 2 of the function f of x. This is equal to infinity. True or false? This right here is also true. Firstly though, I didn't put plus or minus here. In that case, we have to look at both directions. When we have the plus here, okay, it goes straight up, so past infinity. Likewise, when we have a negative here, it also goes straight up, past infinity. So therefore, when we have just approaching 2, is indeed infinity, because again, both are going to infinity, so that's also true. And then D, I'm saying that the limit as x approaching 3 of the function, this right here is equal to 4, and then E, it's not none of the above anymore. E, I'm saying that the domain of f is from negative infinity to 2, union 2 to infinity. So yeah, D and E is they are the harder ones. So which one? Which one is false? D or E? Let's see. There's only one false, which is actually the correct answer for this question because we're looking for which one is false. I think the first person who got this is Luffy. Yes, D is false, but therefore that's the answer. This right here is false. This right here is false. Why? Let's talk about it. Okay, we have an open circle here. As x approaching 3, it's actually 2. So I would like to tell you, if we say the limit as x approaching 3 of the function, we look at both directions, right? When x is approaching 3 from the positive direction, it's 2. If we count from the left-hand side, it's also 2. So in fact, this right here gives us 2. This right here is correct, not 4. When you want to say 4, which you notice that there's a closed circle, you can say f of 3. And this means x is exactly equal to 3, right? So you look for the closed circle. This right here is equal to 4. This is correct, but not this. Yeah. And some of the students actually chose E. The domain of the function is negative infinity to 2, union 2 to infinity. This is actually correct because when x is equal to 3, we actually have a value for the function, namely 4. So 3 is actually in the domain of the function, but 2, you see that we have a vertical asymptote. This means that x cannot be equal to 2. So this is actually the correct domain for this function. Even though we don't have an equation for this, but you just have to understand how the graph works. So that's it. These are just the multiple choice questions though. So for the multiple choice questions, I like to use them especially for conceptual things, and also I can ask like multiple questions in a question. I actually had one of my dream job is like just to write test questions. Yeah. I thought about it, never had the opportunity though, but like once I became a teacher, of course, that's like one of my responsibilities. So I enjoy doing that. So I always tell my students that, you know, if you have like my old exams, doesn't matter because I'm going to be writing new ones. I just like to write exams. So if you have collected all my old exams, good. Yeah, good. But you'll see new ones. Okay, so we are all done with all the multiple choice questions. Now moving to the short questions or the fill in the blanks. So number 11. Number 11. So you can see that a lot of these questions are based on graph because we are talking about limits and continuities, and it's like an introduction to calculus and all that stuff. So let me give you guys a picture first. Right here, we are given the graph for f of x, and this is like a crazy piecewise function. We have this, and this right here is 1, and then we have an open circle here. This is 3, and then like this, closed circle, and then it drops down to this, like that, and then the x value here is 2, and this right here is 0. Okay, so that's 0. This is meant to be an open circle, this is 0. Okay, that's all we need. Now, part A, I didn't really label the parts, but like, it's okay. What's the limit as x approaching 2 plus of the function? So I think I'm going to write down the questions so you guys can answer. And the second one, what's the limit as x approaching just a 2 without the plus or minus here? And then we have this. And then lastly, how about the limit as x approaching 0 of the function? Okay. So, number 11. What's the first one? 1, that's correct. When x is approaching 2 positive, we look at, use your right hand and then just kind of go to the 2, right? And you see the y value is just 1. Even though I know this is horizontal, but it's just 1. Yeah, so 1 is okay. How about second one when we do not have the plus or minus anymore? This right here is D and E. Very good. Does not exist. And remember, whenever we are doing the limit, if it does not have plus or minus, especially if it's a piecewise function or that there's a jump or so, make sure you check both. So let me just write this down real quick. When we have the limit as x approaching 2 plus of the function, as we talked about it earlier, this is equal to 1. But if we look at it from the other direction, 2 minus, this right here, you see, it's actually 3. So you can see that these two are not equal. Not equal. So therefore, it does not exist. Similarly, for this one, when x is approaching 0 without the plus or minus, you see if you go from the left hand side, it's 1. If you go from the right hand side, it's 3. So again, this right here does not exist. Okay? Alright, so that's number 11. Alright, now moving to some like heavy duty computation. Not so bad, I will say, but like of course my students wouldn't agree with me for some of the things that I say, especially when I tell my students, this question is not so bad, and they'll say, no. Anyway, number 12, we are given that f of x is equal to, the function is 1 over 2 plus x squared, and I said it specifically that we will have to use the definition of the derivative to get f prime of 2, right? So I'll just put it down here. So that's what we have to do. So to use the definition of derivative, of course, what you can do is take a look at my board right here. But no, just kidding, of course. Well, not really kidding, you can look at that. You have to remember the definition of derivative in terms of the limit, which is the limit as x approaching 2. And I would suggest you guys, if the question is asking us to find the definition of derivative, use this version. It's easier in my opinion. So x is approaching 2, and right here, we are going to put down our function, and that is 1 over 2 plus x squared, and then minus, we will have to put 2 in here, which is 1 over 2 squared is 4, 4 plus 2 is 6. And then the bottom is just x minus 2, like that, right? So again, we got this because right here we have to compute f of 2, which is 1 over 2 plus 2 squared, which is 1 over 6. So that's for this. So this is a setup, and after the setup, it becomes a limit question. And this has complex fractions. So to take care of that, let's just multiply the top and bottom by this and that. So that's 6 times 2 plus x squared. And I know students, they don't like to write down the LIM. If they didn't write it, I'm lenient, I didn't take away any points. But just have to remember, it's a limit as x approaching 2, and then you have to do the algebra right here. Anyway, we take this, multiply by that, 2 plus x squared will cancel, so we have a 6 right here. And then in the middle we have a minus, and then the 6 and 6 will cancel, so we have that 2 plus x squared, and be sure we use a parentheses. On the bottom, let's put down the 6 first, and then x minus 2, and then 2 plus x squared. So that's just the algebra part. And let me tell you, a lot of students, they tend to just see the 2 plus x squared and also the 2 plus x squared. They look the same, and they both have parentheses. They will just cancel them out, but that's not good. This is not allowed, because the top right here has 6 minus that. We haven't done the top yet. So let's go ahead and distribute this, and we see that this is actually the limit as x approaching 2. So when we do that, we get 4. Just put this down, yeah, like 4. And then minus x squared over this right here is 6 times x minus 2 times 2 plus x squared. Now, notice that at the top we have 4 minus x squared. We can almost factor it to be the same as that. Yeah, one of the factors will be the same. But the order right here is kind of not what we like. So when we want to factor 4 minus x squared, we can actually switch the order of subtraction, but we just have to negate the result. So this is the same as negative x squared and then minus 4. Usually we like to have x first, right? If now we can just switch it. And then by looking at this, this is just a difference of 2 squares. We can factor it, x minus 2 times x plus 2. Right? So this is the correct factoring for the top. Some of the students, they missed the negative because they didn't really switch, so that's why they missed that. But here is just a limit as x approaching 2. I'll write that down again. We have negative x minus 2 times x plus 2, and then divided by 6 x minus 2 times 2 plus x squared. And let's just cancel it. This and that actually can cancel. And then finally, we can just put a 2 into all the x's. So the top is negative, and then 2 plus 2 over 6 right here times 2 plus 2 squared. All right? What's the answer? Negative 4 on the top. This is 6 times 6. So negative 4 over 36. Magic happens. You get negative 1 over 9. Okay. Reduce the fractions, you guys. I think this is a really bad calculus students habit. Like, reduce the fractions. I see in the comment that you guys wrote negative 4 over 36. No, reduce the fractions. I don't know. Like, I have seen it so many times on my calculus, from my calculus students. They will really just leave the answer like negative 4 over 36, or sometimes they will write it like 2 over 4, and like, come on, reduce the fraction. Reduce the fractions, reduce the fractions. Oh, thank you so much, Nathan, for your super chat. Thank you so much. Yes, reduce the fraction, reduce the fraction. But this is how you do number 12, and in my opinion, this is one of the longest one on the test. I shouldn't say the longest one, because if you guys look at the last question, yeah, it might be even longer than that. But it's one of the longer ones on the test, for sure. Hello, 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 hello. Hello, thank you everybody for coming. Thank you everybody for coming. We have a couple more questions, and yeah, it's 11:50 p.m. So I will have to hurry up. Right. Number 13. I am giving you guys the piecewise function. So no graph. If you want to have the graph, you will have to graph it on your own. Here we have negative x squared plus 1, and this is good if x is less than or equal to 0. And the other one is cosine x, and this is if x is greater than 0. And some of you guys might notice, if you have taken Calc 2. If you're just watching this Calc 1 video for a review or just to have fun on a Thursday night, yeah, this right here and that, they actually connected really well. And I can also talk about the Taylor series, but yeah, it's also like some denominator I didn't do, but it's okay. Anyway, number 13. This is the piecewise function, and we have our first question. The limit as x approaching infinity of the function. B, we have the limit as x approaching 0, f of x. And then C, we have the limit, oh sorry, the first one is negative infinity. And then the last one, x approaching past the infinity of the function. Okay, number 13, we have this piecewise function and we have these three little limits. Okay, so what's the first one? What's the first one? What's the first one? What's the first one? The first one is not 1. Negative infinity, Carlos, yes. This right here, when x is approaching negative infinity, x is less than 0, so we refer to the first piece. Negative x squared plus 1, as x goes to negative infinity, you actually end up with negative infinity, alright? So let's figure this out in our head first, and I'll show you guys the graph. Now, part B, what is it? When x is approaching 0 of the function. Part B, this limit is equal to 1. And we will have to really be careful when we have a piecewise function. We will have to plug in 0 for the first piece, which we get 1. And we also have to plug in 0 for this. Cosine 0 is also 1. So that's why the answer right here is 1. We have to make sure the left and also the right limits, they both equal to each other. So that's 1. Lastly, how about this? The limit as x approaching infinity. D and E, yes, this right here does not exist. So this is similar to one of the multiple choice questions that we did earlier. Okay, let me see. Oh, number 14 how to write, so I'll just give you guys a big picture here. All right, I will grab this in red. Negative x squared, right? X squared looks like this. Negative x squared is just the upside down version. And then you add 1 to it, you just bring up that 1 unit. So you have a picture that looks like this. So this is when we have negative x squared plus 1. And now, let's look at cosine x. Earlier, I should also have mentioned this is x less than or equal to 0. So this right here is solid point right here, all right? For the second piece, we have cosine x. Cosine 0 is equal to 1. Even though it's not included, but when we have the 1 earlier, it was 0, 1 already. And we just picked up that point, and then we just do the cosine curve. So this blue one is the cosine graph. How pretty is this, right? And you might see that this part is like, wow, really, really cool. Yeah, but I'll talk about that in calculus too later on. So with this being said, when x is approaching negative infinity, you can see that the curve goes straight down. Well, I shouldn't say straight down, but it goes down, always downward. So we have negative infinity. And when x goes to 0, left and also the right limit both equal to 1. And lastly, when x goes to past infinity, right, it's always jumping up and down between a negative 1 and 1. Therefore, does not exist. Okay, cool. Wow, we have 168 people watching. Thank you guys so much for coming. At this like a very random hour. How many of you guys are in the United States? Or like America, like this time zone? Because right now it's like almost 12. And if you're in the East Coast, then it will be like almost 3. Oh, Vancouver. Okay, nice, nice. Oh, 2 people from Vancouver. Cool. Marcos. Okay, cool, cool, cool. I'm in California too. India. What time is it in India? That should be in the daytime, right? I believe. Wow, so many messages that I cannot read them all. I'm sorry, but like, cool. And then Florida. Cool, cool, cool. And then Turkey. Wow. Okay, let's just go ahead and continue. We finished 13 questions already. I thought I was able to finish the live stream in an hour, but I think I explained a little bit too much. But anyway, though, it's fun to entertain you guys and also to interact with you guys. Number 13 and number 14, they are actually from the same question. You can take a look. So let's do number 14 first. This is the limit as x approaching -2, and we have x to the third power plus 2x and then plus 12 over x plus 2. So I saw a lot of my students, they were able to just do a long division for this, and everybody was happy with this, I would say. So I would like to show you guys a synthetic division. Notice when you plug in -2, we end up with 0 over 0. So that's why we have to do the work. And this is a cubic curve. It's hard to factor the usual way, right? But it's okay, just do the division. Synthetic division in action, put down the coefficient right here is 1, but we don't have the x squared term, so we put down 0, and then we put down 2, and then we put down 12. And then we look at x plus 2, but we actually have to make equal to 0, x is -2. I'm going to put down -2 right here. Just do the opposite of this, right? And then let's just go ahead and do the work. First, bring down the 1, and then we do this times this, which is -2. I'll put it here. And then we do this plus that, which is -2. And then we take this times that, which is going to be 4, and then we put it here. And then 2 plus 4 is 6. And then we take this times that, which is -12. And when we add them, it's 0. Okay, originally we started with x cubed. These right here will be the coefficients, starting with x squared and then x, no x, and no remainder. Yeah. So this right here actually becomes the limit as x approaching -2. Again, all this right here will become x squared minus 2x and then plus 6, no x here, and then yeah, that's very nice, huh? And now we can just plug in -2, so we get -2 squared minus 2 times -2 and then plus 6. And this is one of the little things I need to do. You see, this is question number 14. Let me tell you, the answer is also 14. Yeah, it's just a small touch. But I cannot do this all the time because otherwise my students will figure, oh, hey, if it's question 15, the answer must be 15. But once in a while, it's okay. Okay. So this is the way that I expect my students to do it, or you can do the polynomial long division, depending on which one is more comfortable. Now, the next one, as I said earlier, number 14 and number 15, they are extremely similar. It's because they are from the same question. But let me just work it out the way it is. The limit as h approaching 0, and here we have -2 plus h to the third power, and then we have plus 2 times -2 plus h, and then plus 12 all over h. So of course, the hardest part is this, right? Because we have the third power, but it's okay. Just multiply it out 3 times all that stuff. So I'm going to just probably put down the work right here. So little note should be okay. All right, so -2 plus h times -2 plus h times -2 plus h. Of course, I know some of you guys will say, let's use the Pascal's triangle. Yeah, but if you have not seen that before, then just write it down 3 times and multiply it out. Yeah, shouldn't be too bad. Okay, multiply out these two terms first. So we have negative 2 times negative 2, which is 4. This times this is negative 2h, right? And then when we do this times that, that's another negative 2h. So in the middle is negative 4h. And then h times h, which is plus h squared. And we have to multiply it out one more time. So I will take 4 and multiply with this and that. So we get negative 8 plus 4h. And then I will take this, multiply this and that. Negative 4h times negative 2 is plus 8h. And then minus 4h squared. And then I will take this times this, which is minus 2h squared. And lastly, this times that, which is plus h to the third power. I know we can simplify a little bit, but I will just put down the result right here. Save some space. Okay, firstly, we can combine. Well, let's write down a negative 8 here, right here. And this and that together is just 12h. So plus 12h. And then this and that is minus 6h squared. And then lastly, we have the plus h to the third power. So this right here gives us the perfect cube part right over there. Okay, and then we can just distribute this, which is negative 4 plus 2h, and then lastly we have the plus 12 and all over h. Now we can simplify more. Notice negative 8 minus 4 is negative 12, and then plus 12, they will add up to be 0. Very nice. Not only that, the rest of the stuff, they all have an h, so we can factor that out. So let's factor out the h. Here we get 12, here we get negative 6h, here we get plus h squared, and here we get plus 2, and then over h right here. And we see this and that cancel. Now put 0 into h here and here, so they become 0. So lastly, it's just 12 plus 2. So we end up with 14. And yeah, told you. I know, it's not 15, right? Question 15 is not 15, but I told you guys why already. All right, so take a look real quick. So yeah, this semester I'm teaching Calc 1, just one calculus class. So I don't think I will like do any live stream with that calculus 2 exams, but we'll see. Yeah, depending on what we want to do. Okay, now let me just erase the algebra part. And I feel a little bit tired, to be honest, because it's late and then I had a class earlier too, so 2 classes. Okay, let's talk about why they are actually from the same question. In fact, this and that limit, both of them, so I'll just write this down, both number 14 and number 15, these 2 limits represent the derivative of some function f prime of, look at this right here, it's easier. It represents f prime of negative 2, where the function is x to the third power plus 2x. If you look at number 14 and refer back to question number 1, yeah, it's the same form. X approaching negative 2, so yeah, negative 2 right here. And this is the function. And you bet if you put negative 2 here, we will get technically negative 12. It's like minus negative 12. That's why we end up with the plus 12. Yeah. However, 14 and 15, I expect my students to do this. But if you encounter these questions on multiple choice questions, the easiest way to do it is recognize that these 2 limits, they represent the derivative of some function at some point. Then you can just use the power rule, because check this out. I can just say f prime of this is just 3x squared plus 2, and then plug in negative 2, and then we get 3 times negative 2 square plus 12 plus 2, and you bet it's equal to 14. Alright, so take a look. And if you guys are taking Cal 1 right now, let me know in the chat. Okay. So yeah, let me know which calculus that you guys are taking, either Cal 1 or Cal 2. Turtle T, thank you so much. All right. Oh, you're in pre-calc. Wow. So you guys just getting a head start. But like the first part of calculus, like the things that we're doing were just limits. So that should be beneficial for you as well. Oh, cool. And then you're not even in calc yet, but you understand something that you home. Okay, cool. All right, now number 16. Number 16. Let's take some derivative, ddx, and then here we have x plus 4 times x squared minus 4x and then plus 16. Hey, we have a product of two functions. Shall we just use the product rule? I'm looking at you guys. I have a little screen over there. I have my laptop there. Calc 1 is for limits and derivative and some integrations, and Calc 2 is mainly integrations and also infinite series. At least that's how my school works. Okay, shall we use the product rule for this? If you do the product rule, you can still figure this out. I saw some of my students did that, they still got the correct answer, but don't do it. Remember, always try to do algebra first before you do calculus. That way, your life will be so much better. Because that would be an example right here. So let's see, if we multiply this out, so you'll see that if we multiply this out, so I'll just take this and then multiply, right? So we get x to the third power minus 4x squared plus 16x. And then we take this times this times this. Yeah? So we have 4x squared and then positive times negative, so it's negative 16x. And then lastly, we have the plus 64. Right? So in fact, inside, it's actually very nice. We just have to differentiate what? X to the third power, and then this and that cancel, and then plus 64. Power rule in action. Because when I put on ddx, you don't have to use the definition of derivative. Just go ahead and do it. Final answer, 3x squared plus 0 plus c. No, don't do that. 3x squared, then we are done. All right, moving on to number 17, I shall be able to squeeze that in right here as well. Okay, take the derivative of the cube root of x over x minus 3. Okay, for this one, we will need to use the quotient rule, and unfortunately, we cannot simplify it. Yeah, because we have two things on the bottom, so cannot really break them apart, right? So let's just go ahead and do the quotient rule. We are going to square the denominator. So right here, I'm going to just write down x minus 3, and then we square that. Always square the denominator right away. And then we'll put on the bottom function, which is x minus 3 times the derivative of the top. Okay, let's look at the derivative of just x to the 1/3 power. This right here, in fact, I showed you guys that for the first question, right? This right here gives us 1/3 x to the negative 2/3. We can just use the power rule for this. right? Bring this to the front and then minus 1. I'm going to just write it as 1 over 3 and then x to the 2/3 power like so. I'm not going to put this back into the radical form yet, right? So this derivative is that. And then we minus the top function, which is the cube root function. I'm going to just keep it as the power form, which is x to the 1/3, times the derivative of the bottom. Derivative of x is 1, derivative of minus 3 is 0, so this right here will be it. This is it for the calculus part. The rest is just the algebra. Now we see we have a complex fraction, so let's just go ahead, multiply the top and bottom by the common denominator, which is just this. So we multiply by 3x to the 2/3 power. Okay, let's see what we end up, okay? What we will end up with. When we take this times that, they cancel, so we just have x minus 3 for that part. Then we minus 3, and then x to the 1/3 times x to the 2/3, we add the exponents. 1/3 plus 2/3 is just 3 over 3, which is 1. So we have x to the first power. And then the bottom is just all that, but let me put this down first. 3x to the 2/3 power, and then x minus 3 squared. Yeah. And then we can just combine this, right? X minus that. So finally, I'm just going to write it as negative 2x minus 3 over this thing, which is 3x to the 2/3 times x minus 3 to the second power. So that would be the simplified answer, and that's the answer that I'm looking for. That's it. Repeat the second step. This is the quotient rule, so okay, let's see. Right here, we square the denominator, and then we put on the bottom function, which is x minus 3, times the derivative of the top. And the derivative of the cube root, you can do the power rule right here. You write the cube root as x to the 1/3 power, bring the 1/3 to the front, and then you do 1/3 minus 1, which is negative 2/3. X to a negative 2/3, we can put that down at the bottom. So that's why we have 1 over 3 times x to the 2/3 power right here. This is the derivative of the cube root of x. And then minus the top function, and then just wrote it as x to the 1/3 power, times the derivative of the bottom. Derivative of x is just 1, derivative of negative 3 is just 0, so this is what we have. Then we multiply the top and bottom by this denominator. When we take this times this part, this and that cancel, so we just get x minus 3. And then minus 3, x to the 1/3 times x to the 2/3, we just add the exponents. 1/3 plus 2/3 is 3 over 3, which is 1. So we have x to the first power. And then for the bottom, we just put this down first, and then that. And finally, we do x minus that, which is negative 2x, and then just write down the answer. So that's it. Yeah. And I do have a lot of examples on derivatives. You can check out my playlist for section 3.2 for the power rule and also the product rule and also the quotient rule. So go ahead and check that out if you need more practice with this. Okay, so again, for the shorter questions, some of them will be just a straightforward computation. But not the next one though. The next one is asking for some conceptual things, and you have to explain and illustrate. Problem 18 is the big boss. Kind of. I think, of course, I went over all this in class, so I would say all the questions are fair games, right? Okay, number 18, you guys can see right here. Well, just look at the file. What are the 3 cases of a function that fails to be differentiable? So I'll just write this down right here. 3 cases for a function f not differentiable at some number. All right. And I also tell you guys, I also say on the test that you have to give the name and also draw a picture to illustrate. So what are the three cases for function not being differentiable? All right, so not being differentiable at a number, all right, so keep that in mind. So case one, and of course the order of the cases doesn't matter, but like I would just say case one. I would just say when, okay, let me just, I don't know, it's 12, 15, I'm a little bit tired, sorry. Okay, case one, I'm just going to tell you guys the three words that I'm looking for, right? So for case one, I'm looking for this word. I'm looking for discontinuous, right? Not discount, right? C-O-N-T stands for continuous in calculus, right? So case one is discontinuous. And you can draw a picture real quick. So a picture that you can draw is like this. Discontinuous, like this. And then maybe put a open circle like that, closed circle like this. That's it. The function is discontinuous at A. It's not differentiable. That's case one. Of course, you can also have the vertical asymptote picture. That's also discontinuous. But you cannot say case one is a removable discontinuity. You cannot say case one is f is not defined. I was not looking for that. The keyword here is discontinuous because for discontinuous, it covers three cases. So three cases for this continuous function, all right? So let me go over this real quick. The first case is when we have a vertical asymptote, like so. So this is a VA, right? Vertical asymptote. And then the second case is that when we have a jump. So that's why we have this, like that, and then maybe jump down like this, right? So this is a jump. And some of you guys might be wondering like, hey, this is kind of like a jump too, right? You jumped from here to here. But in order for this to be a jump, you have to go from finite to finite. So that's the difference. This is infinity and a negative infinity, right? So we will call this vertical asymptote. And of course, you can also have a curve goes like this. That's also a vertical asymptote. And the last case for discontinuous is when we have a picture like that, which is a removable discontinuous. Let me just write this like this and then like this. RD. removable discontinuity. There we go. Yeah. So if you say case one is removable, if you say case one is RD, then unfortunately you're only talking about one case of these three. I will take away a point in that case. If you say case one is vertical asymptote, again, I will also take away 1 point. You have to say discontinuous because that will include all three cases. Yeah, and maybe even the function is not defined will also be okay, right? This is also right here. Anyway, case one, I'm looking for discontinuous. Case two, you guys help me out. I have to take a little break. First one is the hardest one. A lot of my students missed it because of the wording and also the logic. Case two, you guys help me out. Take a little break. I'm getting old. My goodness. The first one is when the function is discontinuous. How else can a function fail to be differentiable? How else can a function fail to be differentiable? You have a sharp edge. Yes. So for case two, you can say a corner, right? You can say a corner, or you can use another word, cusp, or you can also say a sharp turn. So one of these words is okay. Yeah, one of these words is okay. Yeah, because I think most of us use this interchangeably. So I'm going to just draw you guys a corner. Let's say we have an absolute value function like this. This is a corner, and then at A, the function is not differentiable. We cannot draw a unique tangent line for this, right? All right, case 3. What's case 3? What's case 3? Sharp turn technically, sure, yeah. What's case 3? What's the other case that I have not put down yet? Yes, infinite oscillation. I think I know what you mean. There's a term for it, and in fact, we mentioned it earlier. It's one of the multiple choice question as well. Hint for you guys, it's the cubic curve. No, sorry, it's a cube root curve. Yes, Leo Fox Pro. You got it, vertical tangent. So the third word I'm looking for, technically has two words, the vertical tangent situation. So you will have to mention this, this, and that. And the vertical tangent, again, just apply a picture to illustrate, and maybe I'll draw a picture like this, like that, and like this. So here we have a vertical tangent, and let's say this is the A. It's not differentiable over there. So again, if a function is discontinuous at A, sorry, no derivative. If the function has a corner or a cusp at A, or a sharp turn at A, not differentiable. If the function has a vertical tangent, because the slope of a vertical line is undefined. So right here, this is also not differentiable. Yeah. So this right here is just that you have to know all the three cases and being able to illustrate it. So that's for number 18. I think you guys might notice that I actually didn't put any e to the x on this test. I originally have e to the x. I originally had some e to the x question, but like somehow I decided to change it. And then I end up with not putting down any e to the x questions. But anyway though. Okay, number 19. So number 19, we are going to sketch a curve, right? I should sketch a graph for f of x. Yeah, let me just so that. All right, I'm asking to give an example of the graph. So again, this right here is more conceptual. You will have to know exactly what the limits mean in order to come with the graph. So it's like kind of thinking backwards. The first criteria is that we want the limit as x approaching 2 of the function. We want this to be negative infinity. So this is the first criteria. And the second criteria is that we want the limit as x approaching infinity of the function. We want this to be 1. And then the third criteria is the limit as x approaching negative infinity of the function. We want this to be negative 3. Right? So 3 criteria. All right, so let's get started. So firstly, let's just focus on this. X is approaching 2, and notice that it doesn't have the plus or minus, right? And it says it's negative infinity. So that means when we have the plus, it's negative infinity. When we have a minus here, it's also negative infinity. So in fact, we will have a vertical asymptote here at x equals 2. And then the picture will just look like this, right? It goes down like this, and then goes down like that. Yeah. Okay, so somewhat like this, based on the first criteria. And the second one says, we want the limit as x approaching infinity, we get 1. So that will give us a horizontal asymptote. This is one of the horizontal asymptotes. So this is just a horizontal asymptote at y equals 1. So right here, let's just go ahead and put this down. And just go ahead and draw a picture, make it prettier. So this will be okay. If you want to be creative, you can also go up and then come back down. That's fine too, because you can actually cross the horizontal asymptote. Okay. So anyway, this right here is a vertical asymptote at x equals 2, which we did that. And this is a horizontal asymptote, which is this, we did that. And for this right here, x approaching negative infinity, we have negative 3. This is another horizontal asymptote, y equals negative 3. So I'll just say, maybe I'll fix this a little bit. Let's say this is negative 3. Something like this. In fact, if you want, you can go like, oops, too far away, right? It's okay, just come back down. This is totally okay. But if you want to go from here to this, that's fine too. Yeah. So I like these questions because it will force you to really understand how limits tell you about the graph of the function, how the function behaves and all that stuff. Yeah. Okay. Yeah. And again, you can technically cross the horizontal asymptote, like right here, I cross it, it's okay. It's just the end behavior as long as y is approaching negative 3, as x goes to negative infinity, that it's okay. Yeah. This is not the last question though. This is actually the second to the last question. We have a 20 question. Okay. All right, so for number 20, there's actually a little secret between my students and I, so I'm not going to tell you guys what it is. I will just tell you guys that this is the question that you will have to solve if you don't do the things that I told you in class. So I'm sorry for my YouTube viewers, you might not, you don't know what I'm talking about, but for my students, yeah, this is our little thing. Anyway, the limit as x approaching 4, and some of you guys saw it already. We have a 3 square root question, right? So we have a first big square root right here. Oh my goodness. We have 1 plus square root of 6 plus square root of 5 plus x. 3 square roots. And then minus 2 over x minus 4. And you bet, if you put 4 into all the x's, you will get 0 over 0. Yeah, so this is like the finale of the test. So we have to do some more work in order to figure this out. Some people actually did this question and got it right. Yeah, so it's not so bad. I will tell you the answer though. The answer to this is 144, so, sorry, 1 over 144. Okay, let's just go ahead and do it. You can do the derivative if you would like, but I will just do it algebra way. I'll just multiply the top and bottom by the conjugate 3 times. So for the first one, I'll just multiply this. Okay, I will write down the whole thing. This is just to make everything clear. This, and then this. Alright, for number 20, we have 3 square roots. We multiply the first conjugate, so you take the whole square root, you change the minus to a plus, and then the 2. All right, so you have this, and then you also do the same on the bottom. So square root of 1 plus the square root of 6 plus the square root of xx, and then plus 2. Okay, so now we will see this right here is the limit as x approaching 4. Check this out. When we take this times that, the first square root cancel. So we just have the inside, namely 1 plus the square root of 6 plus the square root of 5 plus x. Minus 2, but you square that, right? Because when we multiply out the conjugate, we square the first minus the square of the second. So that's what we have. Okay, and then we just write on the bottom, which is x minus 4 times the square root of the 1 plus the square root of 6 plus the square root of 5 plus x, and then plus 2. And the plus 2 is outside of the square root. So it looks like this. For the top, notice 1 minus 4 is minus 3. So this is just a square root of 6 plus 5 plus x, and then minus 3. So what that means is that we will have to do the conjugate again. Sorry, here's another square root. Yeah. Okay, so let's multiply the top by square root of 6 plus the square root of 5 plus x, and then plus 3. And then let's do the same thing on the bottom. Square root of 6 plus square root of 5 plus x, and then plus 3. Okay, and then this right here is the limit as x approaching 4. And then we get, okay, this square root will cancel. So we just have 6 plus square root of 5 plus x, and then minus 3, but you square that, which is 9. And then just the whole thing again. So x minus 4 times the square root of 1 plus square root of 6 plus square root of 5 plus x, and then plus 2. And then times this thing, which is the square root of 6 plus the square root of 5 plus x, and then plus 3. Six minus 9 is minus 3. So yeah, here we have square root of 5 plus x, and then minus 3. So what that means is, yeah, do the conjugate one more time. So take this, multiply it with square root of 5 plus x, change that to a plus, and then 3. And then let's do that again. Put it on the bottom. So here we have the square root of 5 plus x, and then plus 3. Okay, here this is the limit as x approaching 4. Square root times square root. Again, you know the deal, so I'm just going to put this down, let's say, in the middle. So it's 5 plus x, and then minus, right? Minus. Oh, earlier I should put this minus in red. Better. Minus the square of this, right? 3, which is going to give us 9. And then the whole thing again. So this right here is x minus 4 times. But if you notice the pattern, it's actually not so bad. Of course, I like to say it's not so bad, and then my students will disagree with me. You guys can let me know. But yeah, there are actually other ways to do it, but this is the way that for introduction you will do it. But anyway, let's just finish it. Square root of 6 plus the square root of 5 plus x, and then plus 3, and then square root of 5 plus x, and then plus 3. Finally, ladies and gentlemen, 5 minus 9 is minus 4, right? So on the top we have x minus 4. We can cancel this out. And you knew that, right? You should have known that when x is approaching 4, originally we have that x minus 4. This has to be cancelled in order to make this work. And now, yeah, they are finally gone. Like seriously, thankfully, they are finally gone. So on the top we just have 1. I'm just going to write this down. Last, one more time. So 1 over, put a 4 in here. I will set it up for you guys. So we have the square root of 1 plus the square root of 6 plus the square root of 5 plus x is 4, and then plus 2. So take that, multiply with the other square root, which is the square root of 6 plus the square root of 5 plus 4, and then plus 3. And then one more, which is the square root of 5 plus 4, and then plus 3. I knew 1 over 44 would be right here. See? This is about experience. Yeah. Yeah, if you work this out, just go and try it. You get 1 over 144. Yeah, I didn't do this in my head. I grade all my students' tests. That's how I know it. I don't think I remember all that. Whew. Anyway, though, let's see. Yeah, take a look. Okay, 1 hour and 35 minutes. Not so bad. 5 plus. Why are you talking about 5 plus? What do you mean 5 plus 4 minus 9 is equal to 0? It's equal to 0, but where is that part? Let me see. I think I write down everything correctly. Hopefully that's the case. Yeah. But take a look. So I'm looking at the chat. If you guys have any questions, you can drop in the chat. We're done for the test. We're done for the test. Okay. Happy face. Yeah, 20 questions, done. Yeah. I did explain a little bit too much because I want to make this valuable for all the viewers. Like for example, number 18 and other things I gave a lot more explanation than it has to be. On the exam, on the actual exam, you do not have to show all the steps that I did, right? And in fact, for my students, you guys know, this is the question that you don't want to do for number 20, but you know the deal. Yeah. But for my viewers, you guys, yeah, this is how you're supposed to do that question. Or you can also use the derivative method, but I don't know which one you prefer because the chain rule might be pretty crazy too, so depends. Trig limits, not so much. Let's see. Good question. Did I put any trig limits? I did. For some multiple choice questions, not like the crazy one though, because we haven't gone to the L'Hopital's rule yet, so there were only a finite amount of course, finite amount, but there were only like a very limited type of questions that I could ask for limits. Yeah. Implicit differentiation will be for the next test. So I will do the live stream again for the second test, and for the second test, it will be just mainly derivative methods, derivative techniques. You just take the derivative, take the derivative, take the derivative. Yeah. Okay. So that's it. Thank you guys so much for coming. For exam number 2, I will do a live stream again. I will make sure I put up the test beforehand so that you guys can try the questions first, and you guys will be able to know when the live stream will be and all that good stuff. It's 12:38. I'm going to take some rest. Thank you guys so much for coming again. You know it, as always, that's it.